Okay, so today we're going to go over importing in a file and then loading it into the wizard and orientating it. So to do that, we'll go to CAD import. Brings up our solid import file. So we just need to browse out to the folder that we're going to be working with. So we'll go to my folder. And then you'll select your format. So we have a NEMA box. So then we'll go to import, and that'll bring in the box. And now what we can do is we can go to full screen. Full screen allows us to rotate the box, look around, make sure it is the file that you are intending on importing in. If everything looks good, you'll go ahead and hit done. So if all looks well, we'll go ahead and hit OK. Some options here inside this menu that we'll want to go over are if you've possibly made any sheet bodies prior to or that are included in the solid body that you're importing, and you want to use those as fixture blades, you can simply check the box here and then enter in the blade thickness here. So that's probably not going to be used very often. Another option here are sheet bodies to define boundaries. This is probably one that'll be a little bit more common for some users. Depending upon the complexity of their parts, you may have pre-drawn in some boundaries inside of your own modeling software. These would just be sheet bodies, simple surfaces, and then you would just check the box, and then that would automatically bring those surfaces in and put them on the correct layer for you. So it's just saving you a step from having to do that later. If you bring in a weld table, we can do that as well. And then if you're doing any 2D geometry, if you're putting in for like predefined hole patterns and things like that for a base plate or other items. Once you have everything all set, next you would just go OK. And this loads the part. So now the file has been imported in. Next, we just simply will start the Nucleo wizard. This loads up the wizard, loads up the part. Let's take a look at it from the XY plane looking straight down. So what we need to do is orientate this shape so that the opening of the box is up. There's a few ways that we can do this. One of the more popular ways is to align a face. So we'll click on the option here. We'll click the face that we want to point in the Z up direction, to be this inside face. And now it's asking us to select which bodies do we want to move. So if you have multiple bodies on the screen, you would have to select multiple bodies. You can either select them individually, or you can draw a window if you would like. Once everything is selected, you can go up and hit the green check. That'll open up and bring up our align face with plane. So what we're doing here is asking which face that we selected, which plane do we want to align it with? So I want to put this plane parallel with the XY plane. And then if I choose datum, that will put it at Z0. And then if you choose YZ or ZX, it'll do the same thing, align it parallel to those planes. Choosing the box will put it at the origin point of Z0 as well. Keeping this face upright means that this face will point up in Z. If I uncheck this box, depending upon how it is rotated, it will be where it will go. So for now, though, I do want this facing up, so I'll check this box, and then I can hit OK. And now if we look straight down again, you'll notice that we are now facing straight down. So once that's all set, I like the orientation that my box is in. I want to recenter the part. Recentering the part centers us over X0, Y0, and Z0, and then raises our box 2 inches up from the bottom. That's all part of some presettings that we have under the Nucleo options. If this is how you want your box orientated and everything looks correct, we'll just go on to next. In this dialog box, what we're going to be doing is setting our blade thickness, our base plate thickness, and if we're going to be doing any clamp towers, what clamp tower thickness are we going to be using? So for this value here, we're going to use a standard steel. We're going to select 11 gauge. We're going to use that for the sizing of our interlocking blades, our base plate, and our clamp towers. And then for the clearance in between our interlocking blades, what we're looking for is a overall tolerance of 4 thousandths. So what this means, I'll have 2 thousandths per side. If you'd like to increase that a little bit, maybe give yourself, maybe your material comes in a little thicker, or you just want to not be as tight, just let us know. Next, we're going into the default blade length. So what we're looking at is creating a bounding box around the shape of our solids. So with the box, it's quite easy. And then we're going to look at creating blades that are by default 2 inches further than each one of these blades. And then the offset in Z above the lower Z intersection of that part of the U-slot blade, it just means that we're looking to attain a 1 inch offset. So next, what we're looking to do is our base plate extensions. So again, we create a bounding box around the shapes that we're going to be fixturing. And then we look at extending those out 4 inches. And then that will be the default of the base plate. So by default, what we're looking at having is our blades that stick out 2 inches, and then a base plate that's 4 inches past the base plate of the solids. Some other options that we can do here are we can fit extent to blades. So by checking this box, we're going to ignore these values. And then whichever is the longest blade in each one of these directions will be the extent at which the base plate is extended. Now, a scenario where a blade does not extend out past the part, say I'm only fixturing this side, and this side, and I do not have a blade extending out past here, or maybe the blade is tucked in under to here. The base plate will then be created out to the extent of the part. The intent of the software is to always create a base plate that will cover the part at least. So keep that in mind. The next option below that is to add extension in XY, which means that now we're going to do the same thing as before. Longest blade in each side creates the overall size of the base plate plus the values that you put in here. Corner radii and chamfer. So on each of the 3 corners here, here, and here are going to be a radii, and then in this corner will be chamfered, and this is just a size for that. If you have a predefined sheet that you want to use, so currently this is going to be the sizes, you can actually enter in here, and that will be the predetermined size of the base plate. By setting it to 0, we'll be using the formula that's the software automatically creates. Other options that you can use are create a sketch. So if you want to draw your own base plate, you can do that by create sketch, click on the freehand, or if you have a pre-drawn file that maybe you imported in or something you pre-drawn prior to entering into the wizard, you would just check this box as well. And then if you need to add in if you need the software to draw in any of the additional clearances for the slots for the blades to enter into the base plate, any of the etching, any of the bolt holes, any of that, you'll need to check this box to merge any pre-drawn lines and arcs. Weld table allows us to preload in our weld table. So we have a couple different ones. You just simply select from either the list or one that maybe you have sent us. So we have a large blue coat table here. This is actually a customer's table. So, we can load that in for you if needed. So, and then next, Now we're going to get into boundaries. What boundaries do is they provide a Z-plane for where the blades will stop when they're not intersecting the shape. So for this shape here, we'll just do a simple 2D boundary. So we can do an offset boundary, which is selecting something, and then we just do an offset around it. An envelope, which creates, you select the solid bodies, and then we create a bounding box around the solid bodies again, and then we do how large of an offset of that bounding box to create the size of the initial boundary. Initial height, if not set on this first one, will be set to the highest point in the solid bodies that are selected. Or we can come in here and select. I'm going to come out here and use my midpoint and select the midpoint of this surface. I only need the blades to come halfway up the box. So now I have a value here that is 4 inches, 196 thousandths. I can also highlight this and simply say 4 inches. Now what I'll do is I'll create the boundary. So it's just asking me to select the bodies that I want to create the envelope in. I only have the one boundary, so we'll select it, press the check, and now you can see what we're looking at is a 3-inch offset all the way around the box. So at 4 inches up from Z. If that's the only 2D boundary you need right now, you can hit done. 3D boundaries. 3D boundaries allows us to create a swept surface in either the x-axis or the y-axis or both. And what that'll allow you to do is maybe your shape is not as simple as a square box here. Maybe it is more complex and you want to follow that shape instead of adding in multiple 2D boundaries. So in order to do that, we can simply go create boundaries for 3D boundary. It brings up our create user swept boundary box. So what you want to do is enter in your snap grid. This can be set to however you want to set it. I usually have mine set to 0. And then what you're looking for here is a positive extrusion distance and a negative extrusion distance. What this means is we are drawing this on the either x-axis or the y-axis. So what we need to do is, if that is the only axis that we are going to be drawing on, and then we just want to extrude the sheet each direction, we need to make sure that the values entered in here are large enough to encompass the box and then any extensions out past that a blade might be sticking out. So we can use the rulers on the screen here to kind of look at how big this box is. So if we kind of look over here to the left, this box is approximately 14 inches wide. And then looking down here at the bottom, we can see it's approximately 16 inches long. So if we're going that direction, an overall of 14, so that would be a 14 distance here. I would probably only need to go out, let's say 10 inches in a positive, 10 inches in the negative. And that'll give me 3 inches past the box in now those directions. So if I go at the x-axis, I'm going to sketch a boundary profile. And now what it's asking me to do is just start here and draw. A dialog box is also present that tells us that to draw a series of lines and arcs to define the boundary. Press enter when done. You can use the L and A button to work between drawing a line or drawing an arc. So what we can do is I can start out, say here, I can draw up at an angle. Once I reach this point, I can continue on, however I want to do this. Maybe I want to come up here, and then I can go with an A, which will allow me to draw an arc. So maybe I just want to come up to here, maybe like this. I can come back down where I'm still drawing an arc. Or I can go right back to a line if I want. And then out. So once you enter this and you're all finished, You'll just hit enter. Sorry about that. Do you want to add do you also want to define a path to sweep along? So what it's asking is, do you want to also draw in the opposite axes? So you'll be drawing along the y-axis, or do you just want this to go perpendicular to the x-axis, which is what we want in this instance. So what we're going to hit is no. So if I go ahead and hit done here, I can rotate this out. And now what you can see is I have the two different boundaries. And when you have overlapping boundaries, what happens is it's a sort of like a first come, first serve. So the first boundary that it intersects will be the boundary that it uses. So when looking at it from this perspective over here, when we're outside the box, we'll be hitting this boundary out here, the flat boundary here, then it'll dip back down, come back up, and then we'll go straight back out. So it's a little preview of how you can kind of imagine what your fixture is going to predeterminedly look like if you need to make any changes. So let's say we want to use that 3D boundary that I just created, and I want to ignore this one, the first one. So I'll just go to delete, and then I just select that boundary, and now it's gone. Lastly, our shim plates and shutoffs. So if you have boxes like this or items like this or areas where you don't want that, you're going to have a blade possibly go over an opening, but you do not want the blade to go up into that opening, we can quickly create a shim shutoff by creating the boundary. If we want to make a perimeter offset, maybe larger or smaller, there's reasons for that. But for this one, we'll just leave it at 0, hit create, grab the face that we want to create the sheet body on. And as you can see, it creates an orange body that just simply closes off all the holes. Just asking us here, does everything look fine? Which it does. So we just go ahead and hit apply. Then we're hit done. So now any lines that I draw in here, I do not have to worry about them going up into any of these little tiny holes, which are unnecessary for me to have to fixture. So the outsides of the box will be sufficient for this job. So once I have all the boundaries that I think I would need at this point, I can go ahead and hit next. Or if I need to manipulate any of these boundaries, I can simply move them, tilt them, copy them, scale them, make them larger overall, scale in just the X, scale in just the Y. If you are working with parts that are symmetrical to each other or left hand and right hand parts, you can create all the boundaries on one part, one corner, one area, and then mirror them to either the other side of the fixture or the other side of the part, thus creating a symmetrically opposite side. So there'll be videos later digging in a little bit deeper into the boundaries that you'll be able to check out. So next is if we need to make multiples of this fixture. So what this would do is, if I was going to lay this out and weld together, say, a batch of 10, I can then choose give me 5 in X and then 2 in Y. And then what I want is a gap of 3 inches in between each part, because then that should give me about 6 inches in between. So, and then I do want to include the boundary extent. So it's going to be 9 inches actually. So we hit grid array, and then you can kind of see the boxes here, the blue lines here. Let me do this. I can't do that now. These here would be your other fixtures. So you would draw the one up, complete it, and then it would just put the holes in the base plate for the rest. And then it would tell you to cut this 10 of each part to make each fixture go around. We will not show you each one just because that takes up extra computer space, unless you just want to check the box here, make copies of solids. You can do that as well. If you don't want any of these, you just go ahead and hit delete, or you need to make any changes, just delete, removes them. And then you just enter in new values if need be. Other than that, if you don't need this, you just go ahead and hit next. This value here, what we're going to be doing is selecting and putting in our blade lines. Where do we want our blades to be? So the software has a has an array of different options of doing this. There will be another video as well with the boundaries that'll go a lot more in depth into working with lines and how to work with them, how to mirror them, move them, extend them, and things like that. So for right now, like I said, this is just an introductory video. So we're just going to explain how the auto button works and then some of the other options in here. So the auto button looks at the shape that we're looking to fixture, figures out which length is longer, and then takes the value and splits that into 5 equal sections. And then that's the value that is used for both the pitch and the X and the Y. So if we hit auto on here, we're looking at a 2.6 inch pitch between each blade. Or I can also come in here and say, well, I don't need this many blades along X. I can come in here and say, well, let's take this up to 4. Maybe we'll change this to 3, and then I'll hit create grid. Now I already have blade lines on here. So what this is looking to do now is tell me, hey, you already have some. Yep, that's fine. I just want to put the new ones in. Go ahead and hit yes. There we go. That's much better. A few less here. These are a little bit more spaced out. They'll work out for what I need. So from this point, I'm going to turn off our boundary. And then what I can do is I have a couple options. I can select and arrange lines, which allows me to come out here and grab the line and then pick and place where I would like those lines to be. Maybe I'll move these out to the outside to create an outside perimeter box. Another option I can do is I can actually just select lines. Then I can enter in a value here of say 1 inch and then just tell it which direction to move in. Then I can just keep repeating this until I have the blades in the locations that I would like them to be at. Okay. So once you have the blades in the locations that you want, there's some other options that you can do. We can extend lines, but we can shrink them. Now for this part, what we're looking to do is weld the corner. So I need to be able to reach all the way down up around here and down to the tip. Well, by looking at this shape, I'm going to close off this corner here and not allow that to happen. I'm not going to be able to reach down as far as I need to. So what I can do is I can shrink, and I need to do this on all the blades that go around the outside. And then by how much? Well, I'm just going to start out with 2 inches, X negative. So both of these blades get pulled back 2 inches, and maybe we go 1 more inch. Yeah, that was a bit much, so I got to use the extend version and then extend the line out. There we go. That looks much better. We can do the shrink. Come over here. It was 2. And then we do the positive side here. And then we can go to a 0.5 again, just to get that same amount over here. Next, what we'll do is we'll do these green ones, and those will be in the Y positive negative. So let's go 2.5, and then we'll go negative. Looks good. Positive. Looks good. So that pulls back away from the corners for each of these. So some other options that we have for adding in lines. We can come in here and we can use them by user length, a window, some selected solids, which is very similar to what we're doing here. XY dimensions through a center point, or some existing 2D lines and arcs that you may have on the screen. And again, we'll go over that in a more in-depth video, along with some more options here. So like I said, simply put, we have some simple lines on the screen by using the auto command, changing these values slightly, and then just arranging them by hand and doing some quick moving and shrinking. Once everything's set, what we'll do is we'll go ahead and hit next. And now we're just looking for how are we doing this with the tabbing? What kind of tabbing style do we want to use to the blade? For this one, we're just going to use a default non-locking, which means it's just going to be a simple tab sticking through the part. We're going to use a 2-inch spacing with a tab depth of 115 thousandths. I like to be a little bit shy of the actual thickness of the base plate so I don't have anything sticking out the bottom. So the pitch will be center to center on the width of these. So next, if we're going to do any clamping, we'll get into clamping in its own video, but you would simply insert the parasolid file, select your clamp, put it in place, and that'll be it. All right. So next, any torch access. So we're not going to go through that, but that'll simply be if you needed to bring in your own torch that you simply position by hand and then check for collisions. Weld bodies. Anytime you put a weld bead in, if we put that on a layer, we can also increase the weld inflation size, which makes this a little bit bigger, just to make sure that we're not welding a part to a blade. Next is our offset values, gripper points, anything here. This is what's setting up the distance that is between your offsets of your blade and your part. So nominal offset, we're looking for a 10 thousandths clearance overall between the part and the blade. So it's about 5 per side. Do we want any gripper points? Remove small elements. So what we're going to do is remove any tiny elements that may cause an issue when you get out to your laser to cut it by reducing them down to a minimum value of this that you enter in here. If you want any slot depths for friction, that's going to be in the value here, just little notches in to reduce friction. Gripper points, if you are using gripper points, what's the interval center to center? Notch corners and interference points. If you have any sharp corners, if you check this box, what that'll do is, kind of zoom in here on this one. If you have a sharp corner that you would come into, the blade would then create another box in this corner that would just clear out the corner for you. So offset blend radii does the same thing, as it looks for larger radii, not ones like this, but that would then automatically offset a certain amount of that radii. And we'll have more information on the web series of videos to go through these to show you options. Next would be weight reduction. Weight reduction is simply just removing and cutting in windows. So we can reduce the weight of the fixture down to certain sizes. Go ahead and hit next. These are your overall slot tolerances and undercuts that you're going to be putting in to make sure everything fits together well. Pin towers, there will be a separate video on that. If we're going to be putting in any bolt holes, we'll put some bolt holes in the corners, 3 by 3 pitch, 1/2 inch, a little bit over 1/2 inch for 1/2 inch bolts. If you have known locations that you need to put in, you can pick those here. How are we actually calculating the tolerances in the actual design? So what's our rough scan step? And then we're going to do a fine refinement factor, line reduction tolerance, minimum angle from point to point. What's the algorithm we want to use? So are we using our old version 8 algorithm or the new version 2022 algorithm? Has some advanced tolerances here that you normally don't have to play with or set. We'll go ahead and hit next. If you're going to be doing any logos, which we will not be, so we'll go ahead and hit cancel. Part number identifying label, that's going to be in the lower left-hand corner. Font size, where items are going to be. The U-blades, are they going to be on the base as well? What position? It's going to do auto. Maybe you might need to put these on the end of a blade vertically, and then we can tab them out. That's what the tab would be. And then we go ahead and hit next. And then we'll bring up our editor. Once we get to this step, it's simply building the fixture at this point. So we'll go ahead and hit build fixture. All right, so we're getting the blades made, putting in the tabs now for the base plate. And have our fixture report. It's kind of telling us what was done, what was used, any lines and arc reductions, how many elements were eliminated. So once we're done here, and zoom in and take a look at the part. So based on some settings that we had checked is why we have what we're looking at here. So this would be that offset arc. It even does it on boundaries. And that's why you're seeing it here as well. But as you can see, that boundary is why that shape is like that. So, and done. All right, so you have your fixture made, everything is all set. You're happy with how it looks. What we want to do is go up to check. Check is just going to make sure that we don't have any collisions between the part and anything. So we are looking for items here that are marked in red. Don't really see anything. Everything looks good. Go ahead and hit done. Everything's all set. Then we can go to our CAD export. CAD exports are going to be your geometry layer name, text cutout, small font. So if your nesting software requires these to be a certain layer name on a certain layer and a certain color, you're going to want to set those now. And then if you want this to be user, it's just going to get their fixture report. It's going to tell you who made it. Some check boxes here for what's going to be outported, how it's going to be output, and where it's going to be output down here. So go ahead and hit export. And then you'll see it's just going to quickly make the blades and the base plate DXF files. And we get our fixture report telling us how big of the linear length each blade is going to be cut, the size of the blade, and how many of them need to be cut. At the end, we have an overall perimeter of being cut, estimated weight, total number of parts. And then we also have our fixture box that tells us where, just opens up the file explorer where everything's been saved. So you have all of our DXF files for our blades, STL file, pictures, XT file, Parasolid file that you can import into your own modeling software. And that's it. So that is the quick and easy how to create a simple fixture inside of the Nucleo software. So be sure to check out more of our videos coming. That's going to do more in-depth analyzation of each of those wizard pages, getting more in-depth into doing blades, boundaries, and some more advanced functionality that the software offers. If you have any questions or anything, please make sure you reach out to our support team at support@OPTISOLUTIONSUSA.com, or you can call us on the phone at 678-625-0053, extension 2002.